How are you? Do you like the conference so far? Okay, thank you. Yeah, as he said, I'm Michaela, self-employed front-end developer and UX designer from Berlin, and I'm here to talk about WebXR. So, in detail, I will show you how you can use React and React 360 to create VR experiences in the browser. But before we come to that fun part, I will give you a short introduction to the API that makes this all possible, the new WebXR device API. So whatever library you will use, yesterday you heard about Vero, for example, or React 360, whatever library you will use to write your VR or AR apps, you will now then have a fundamental knowledge about how WebXR works and what to consider when designing a WebXR app. And speaking about design, as you may know, UX design is always essential to the success for any web application or any application at all. And since VR and AR are relatively new in the browser, I will give you some tips and best practices for creating a great user experiences in your 3D apps. Okay, now what is WebXR after all? XR basically includes virtual reality and augmented reality and everything in between. So a quick reminder, virtual reality uses a head-mounted display with two lenses to show us a stereoscopic image for each eye, and it has tracking sensors. And some, like the Oculus Rift, for example, or the HTC Vive, come with two gamepads for each hand that also have tracking sensors. And with a setup like this, your users are drawn completely into a fully virtual environment that shuts out the real world. Augmented reality, on the other hand, does not draw a user into a digital world, but it rather superimposes our real world or a live view of the real world with virtual content. And this virtual content can be basically anything like real-time information or data enhancing the real world or virtual objects like monsters and portals. And they are looking like they'd exist in the physical world. And last but not least, there's this term MR or mixed reality or merged reality. And the goal of MR is that the digital content coincides and interacts with the physical world. So you see in this picture here, the three-dimensional cube thingy is not like a transparent layer anymore on the top of the world, but it adapts lightning, casts shadows, and most of all, it disappears behind the chair. So as you can see, the X can stand for everything and maybe even for technology we do not even think about today. But what we can do today is write virtual and augmented reality apps with JavaScript. And therefore, the W3C Immersive Web Community Group is working on a new API called the WebXR Device API. And this API aims to detect devices with virtual or augmented reality features and get their capabilities. And the API also intends to get a device's orientation and position and to render images to the devices with an appropriate frame rate. The new API is replacing the deprecated WebVR API, and it's currently unstable and a draft, but you could already work with it and experiment with it and maybe give feedback to the people writing the API. Okay, but why do we need a new API anyway? What was wrong with the WebVR API? First, the new API now also includes functionality for augmented reality as well. And as you can imagine, I guess, when writing things twice, the new API should be cleaner, more consistent, and more predictable. And promised are also more browser optimizations in regard to performance. For example, they say, I didn't check, they say that you will get 2 times the number of pixels at the same frame rate on a Pixel Phone XL. And last but not least, the WebXR device API now exposes a unified input model that works across all form factors. Because managing input with the WebVR API and the Gamepad API was always a kind of a challenge, and the new API tries to fix that. Okay, now let's see it in action. What steps do we have to go through to create a WebXR scene? So first, we have to check if there are any devices with WebXR features, for example, a modern smartphone working with Chrome and the Daydream View headset. And then, if a device is available, we want to show our users that the website or the web apps offers a WebXR version. And a common way to do this is showing a button to start the virtual or augmented reality content. And when the user taps or clicks the button, we have to request a so-called XR session from the device. And only within an XR session, we are able to get the device's tracking information or render images to the device. And after starting the session, and some setup, I guess, we can start the render loop. And this render loop will continue to produce frames until the user exits the XR scene or we end the XR session. Okay, now let's begin with step 1, requesting an XR device. So an XR device, as I said, can be basically anything with a screen. On a desktop computer, you would request like a VR headset, like the Oculus or the HTC Vive. And on a smartphone, you could request to render to the display itself, but in a stereoscopic way, or you do not render stereoscopically at all. And to request the XR device, we use the Navigator XR object that has a list of XR devices. And the request device method returns a promise that is resolved with the default device, if there's one available. And with the return default XR device, we can now use the method support session to check if the default XR device actually supports the so-called exclusive sessions, which means we require a headset to draw on. And if the device is a VR headset where we can draw on stereoscopically, the promise gets resolved. Okay, what I did here is adding a button to the website advertising the VR feature to the user, because requesting an actual session at the moment, and I guess it stays that way, requires a user gesture. When a user clicks the Start VR button, we can request the session from the device with the request session method, and this method takes 2 optional parameters. One is a Boolean to check if we are requesting an exclusive session, and the second is an XR presentation context, which is the context of the canvas element we want to draw on. And this promise gets resolved with an XR session object, an object we can use to get the device's pose or information about the user's environment, and then present images to the user. We use the session to initialize everything before we start the render loop. So first thing we do is requesting a frame of reference. And this frame defines where the origin of the coordinate system is calculated from and what happens to it when the device moves. So there are currently 3 different types of frame of reference. First is head model, then there's eye level, and stage. And head model means that the origin is approximately a user's head, and it stays the same even if the viewer moves. This is interesting for devices that only can track a user's head rotation, but not the position, like a smartphone with the cardboard. And it is also useful when we are viewing panoramic or 360 degrees videos or images, because this material is intended to be viewed from a single point of view. Then with eye level, the origin is also approximately the user's head, but this time it moves with the viewer. And stage means that the origin of the coordinate system is the center of the room at floor level, and it stays the same even if the viewer moves, which you can use when you have room scale VR. So the request frame of reference method returns also a promise that gets resolved with an XR frame of reference object. And before starting the render loop, we also need to set up an XR layer, or to be exactly, it's a WebGL layer. So this layer allows WebGL to provide the bitmaps to be rendered to the device. To set a new WebGL layer, we use a method from the WebGL context of the canvas object, the setCompatibleDevice method. And it also returns a promise, and when it gets resolved, we can create a new XR WebGL layer with the XR session space layer method and the new XR WebGL layer method, which it expects an XR session and the WebGL context. And then finally, we can start the render loop by using the XR sessions request animation frame method. We will call this method recursively, which makes that the function will be called 60 or hopefully more times a second. And within the render loop, we can do calculations needed to draw the next frame. For example, getting the device's position and then draw something on the screen if we have a correct position. And also, if your app listens to user input, we could process it here before calling the request animation frame function again. Yeah, and that's basically it. You may want to end the WebXR session either manually or by listening to the XR sessions end method, which may be triggered if the headset was disconnected. And the end method returns a promise that gets resolved when the presentation to the VR device has stopped. And once the session has ended, you may want to continue rendering the scene, but in a non-stereoscopic way by using this time then the known Windows request animation frame method. So what we have done till now could look like this. And this is cool, but we may want to support more devices than just VR headsets with a stereoscopic view. A common solution would be the usage of a 3D scene that works with the gyroscope of the smartphone or with touch and click mouse drag and drop input to look around the scene. This is often called magic window because it has the appearance of a window showing us another world. So whatever VR device for whenever a VR device for the stereoscopic rendering is not available or yet requested, we could show the exact same scene, but as a magic window. And the cool thing about the magic window mode is that it does not require a user gesture to be started, so we can just render our content to the page when it was loaded without requiring the user to click any button or similar. And to start an XR session for a magic window, you can use the XR session creation method and set it the option exclusive, this time to false. And with this in mind, we could provide a WebXR app that initially renders a magic window to use the smartphone's gyroscope if available, and then we could check if there are VR devices that support exclusive sessions, and then we could render a button requesting an exclusive WebXR session to render stereoscopically to the headset. Okay, let's shortly talk about one of the most obvious problems from VR in the web, or maybe the web in general, I guess. There are various devices, screen sizes, browsers, operation systems, or input modes. I mean, our users do not always have like a 6-degree of freedom headset with 6-degree of freedom game input controllers and room scale VR. And not everybody yet has a smartphone with AR Core and AR Kit support. I guess your users could also be using something like the Cardboard or the Daydream View or the Gear VR, which are 3-degree of freedom headsets with only one or no input controller at all. So how do we handle this kind of situations? I think we should start by making the experience work on devices with less capabilities and features too, and then improve step by step by using progressive enhancement. With the WebXR polyfill, we can make the code run in browsers with no WebXR support, and we can use the magic window technique to support hardware on which stereoscopic rendering makes no sense, for example, on desktop computers, or on smartphones without any VR headset attached. And in the rare cases where no 3D works at all, we could just render a static site or image or video. In the future, the WebXR API will also implement functionality for augmented reality as well. So you will be able to start an AR session, you will get methods to do hit tests with the real world, detecting planes and surfaces, and you will be able to set anchors. And these anchors will allow you to specify poses, so orientation and position of virtual objects in the real world. And then whenever the knowledge of the real world improves, for example, by more tracking over time, the anchor can improve its visual up position and rotation as well over time. Now, okay, this is the future. The WebXR API is definitely not ready for production yet. And also the WebVR API needs the polyfill to be available for many users. What we can do today is use libraries like React 360 to create 3D or VR experiences that will run in the browser. React 360 is built on top of React, obviously, and it can be used to create 3D, 360, or VR user interfaces that are mainly driven by user interactions and events. And since React 360, which was called ReactVR, then was released in April 2017, the most common use cases were full-sphere panorama photo tours and interactive experiences to promote products or news. And today I will show you some code for a simple panorama photo gallery with some relaxing photos I took with my full-sphere camera to give you an understanding how this all works. Like you saw yesterday, there are similar libraries. Vitaly talked about Vero, and in my opinion, one of the most important ones is maybe A-Frame by Mozilla. And all of these libraries intend to make it easier to write performant 3D or VR code that runs in many browsers and on many devices. So now the difference between these two is that A-Frame is written using declarative HTML-like components. And while React is better, sorry, that was German. While React 360 is better in handling events, user interaction, and 2D and 3D UI elements, A-Frame is the library you want to choose when you have complex 3D worlds, many 3D objects, complex shaders, and post-processing. And by the way, as far as I know, both libraries, React 360 and A-Frame, are currently using the WebVR API. I talked to Andrew Im from Facebook, one of the core developers from React 360, and he said that they are waiting for the WebXR spec to exit the draft stage before implementing it, which makes sense. But I think we can use both frameworks or all these frameworks now and then just wait for them to change the API when they think it's ready. So I guess it's cool for now. Okay, now React 360 comes with a CLI, so all you have to do is install the CLI with npm install React 360 CLI, then create a new project with React 360 in it, and enter the directory and start the server. And then you would just navigate to your local host 8081 and see the scaffolded example project. And by the way, like React Native, React 360 uses the Metro bundler that runs the local server, serves up the files for your project, and compiles and processes your code at request time. And there are other similarities with React Native. React 362 is made of two pieces, the React application and the runtime, which turns the React components into 3D objects. And this separation is made to avoid all render blocking behavior and always keep a high frame rate, which is especially important in VR apps that will make your users really feel unwell if the frame rate drops and the app gets jittery. Okay, now let's see some React code. So this is the scaffolded project folder, and we will take a look at the client.js, the index.html, and the index.js. Okay, this is the index.html, and I will only show you the body because there's nothing special happening in the header. The only thing we do here is loading and mounting our JavaScript code with React 360 init. And the first argument is our bundle, the main code for the application, and the second is the parent element where we want to render our canvas. This is the code that gets scaffolded by the CLI and the client.js. First, we are importing React instance from React 360 Web before defining and executing the init function. And within the init function, we create a new React instance with some options. And then with render to surface, we actually render what is defined in the index.js into the 3D scene. So a surface is by default a cylindric layer on which you can draw a 2D user interface on. And the last thing that happens here is setting a panoramic background image. And now within the index.js, we find the React code. I left out the imports and style sheets to save some screen space here. The interesting thing is the JSX code anyway. So like React Native, React 360 uses view and text components that we can use to create and style the 2D content that gets rendered to the cylindric surface. And this is how the example project looks like. It's not full screen, it should be. To change the example code to show us a full screen photo gallery, we just would have to, that's strange, we just would have to adjust the client.js and the index.js. Okay, within the client.js, we remove the default background image and we change the render to surface function a bit by giving the create root function object with an array with all our photos at second parameter. And these are the panoramic photos in an equirectangular format, which is specified here as format 2D. And the JSX code within the index.js would look like this. And as you can see, we are using two more components, a VR button and a custom background component. So a VR button is, like a div, I guess, a non-visible container or wrapper element that detects all clicks and click type behavior of various input devices. And to give it an appearance here, we add styling and a nested text component. And the background component is this custom class that listens to prop changes and then sets the environment background image. And by adding on-click listeners to both buttons, the previous photo button and the next photo button, we can change the index saved in the slideshow state. And with this, we set the current background image of the background class. Now let's see if the next video works better. Oh, yeah. That was basically all to create this full sphere image gallery. So you see it's not much code. It has this magic window, and I think at the next scene, you could see that the stereoscopic view also works. Oh no, let's see. So this was actually at a German conference, and I guess I will start, yeah, the stereoscopic rendering. Okay, I guess you have seen that if you know React and React Native, writing React 360 code is not new for you. What's new, however, is how interfaces and user interactions work. So let's shortly talk about user experience design for WebXR applications in general. I will include a few tips for AR apps either, because you probably all want to start working on AR apps too, after listening to Vladimir's awesome talk yesterday. So when you start thinking about user journeys and interaction patterns, you will find out soon that our learned best practices and patterns do not always work in a 3D environment. You cannot always apply your well-known 2D patterns to your 3D apps without any fault. And since 3D, VR, and AR are relatively new into a browser and to our users too, there are no really established UX design patterns yet. But there are some best practices I can share with you. First, and this is not new, give your users feedback and respond to interaction immediately. So the feedback can be visible, haptic, for example, like vibrating controllers, or it can be made of spatial sound, or you would even use all this stuff together. And you could also consider the use of a reticle with different conditions for idling, hovering, and active states. I guess we are in a kind of similar situation like we were in 2007 or 2008 when the iPhone and with it the first mobile sites appeared. Back then we had to reconsider how we present information to our users on a tiny screen or on screens with various sizes and ratios. And now we have to think about how we present the content to our user when there is no more separation between the users and the application. Now our users are finally in our application. And therefore, VR applications do not have a limited viewport, but on the contrary, we have an infinite canvas, and a user only has a limited field of view. And this field of view, of course, may change because a user can rotate her head and look around. So how do we make sure a user finds what he or she is looking for? To do this, we could guide our user's attention with gaze cues. Therefore, we could use spatial audio, lighting, colors, or even virtual creatures with eyes that catch your user's attention. And another tip is that hints are more obvious for a user if you provide them in a 3D context and not as separate text elements. So also, it is more intuitive if a user is able to manipulate objects directly in the scene and not via separate UI elements. For example, the three-dimensional rotation indicator on the right is much better than the text-based hint on the left. There is one illustration and one name I'm always mentioning when I talk about UX design for VR and AR, and that is Bo Cronin's hierarchy of needs in VR. The hierarchy shows that the two most important needs in VR are comfort and interpretability, and only afterwards comes the usefulness and delight of an application. So comfort means that a user can use your application without feeling unwell, and interpretability means that the virtual world feels convincing to the user. And if both needs are satisfied, a user gets this feeling of actually being present in the virtual world, which is what you want to achieve. And while working on my talks and prototypes, I added another part to the hierarchy, which I find even more necessary than comfort, and this is safety. So let's take a look at comfort and safety first in augmented reality. One thing you can be sure of, and I guess we saw this yesterday too, is that a user won't use your app in an optimal AR environment. There's probably not enough space, no large surfaces, and poor lighting conditions. You have to accept that you have no control anymore over the scene. And I think you should consider these scenarios, make user tests, and maybe think about adding different features for these situations. During the design process, it is always important to think about a user's context. So consider the environment your users are using your app in. For example, if the app is mainly used at home, it can be designed for a longer usage, but if an app should be used outside, you should support super short interactions. And thinking and testing interactions is important in AR, but as you can see, also in VR. And to reduce the risk of making a user run into physical objects or even people, you should avoid encouraging so large or sudden movements. And the last tip for a good user experience in augmented reality is to avoid fatiguing your users. So you should respect that holding a smartphone at a certain angle can be really exhausting. So consider to reduce the movement by placing objects at a certain distance. Now, what can we do to make our users safe and comfortable in a virtual environment context? First of all, we can avoid creating environments that may trigger phobias like large, empty rooms, small rooms, hates, or standing on a stage, speaking in front of all these people. And especially, you should warn them beforehand. Also, we do not want to move things fast towards the camera, especially sharp or dangerous or gross things. And we do not want to attach things to the camera or near the camera because a head-up display, for example, as cool as it may sound, is not the best thing to do in VR. And last but not least, you should always respect a person's private space around them. So do not allow objects or avatars or even other users enter these private space. And okay, one last thing we have to talk about when it comes to VR and comfort is simulation sickness. Simulation sickness occurs when our sensory inputs are not consistent. For example, if the simulation would tell us we are in a car race, but we are just sitting still in a room. And there are some best practices you can regard to avoid causing simulation sickness. So first of all, you should not move the horizon and force movement to the user, which means you should not move the camera. If you want animated scenes, allow additional head movement, for example, by putting the camera on a dolly and then animate the dolly's movement. And then don't use acceleration. So constant velocity is okay because we cannot feel it. But acceleration and deceleration, so something like this, should be felt. And when there's no feeling, simulation sickness will occur eventually. And the last two things, you should avoid flicker and blur because they indicate movement. And you should consider adding a stable focus point to your scene. Okay, now, yeah, that was basically all from me. If I had a free wish, I would like you to remember two things from this talk. So first, respect your users and test your product continuously with real users. And second, if you like experimenting with new APIs like WebXR or libraries like React 360, give feedback to the person writing them. Then here are links to the repositories of the WebXR device API and the React 360 project, where you can find more links and information, and most importantly, where you can give your feedback by creating issues. So get involved if you like this. Thank you.